All right, folks, in this video I'm going to try and explain to you a concept, a really cool concept, but one that's sometimes difficult to really grasp, to really internalize. It's called the production possibilities frontier. Now, when we say frontier, we typically mean graph. Okay, so the production possibilities frontier is it's a particular graph. This is not an example of the production possibilities frontier. By the way, for short, we often say PPF. It's a lot easier to say. I'm going to start saying PPF. But I want you to understand what the P and the P stand for, production possibilities. The idea with production possibilities, we do this a lot in economics, where we'll make tables of values, like this over here. And what those are those are the possibilities of certain decisions, okay? And so in order to explain that in just a minute, and in particular, these are production possibilities. And when I say production possibilities, what I mean is this, is each one of these lines, 1, 2, 3, 4, 5, 6, 7, is a different set of possibilities of production. Do you remember our example where we talked about making cookies? Well, we're going to expand that example into making muffins, mini muffins also, okay? And here's the situation. This baker who makes cookies has decided that they're going to expand their operation and they're also going to offer mini muffins. They're going to sell both cookies and mini muffins. But this baker still only has one oven, and therefore, and still can only work 3 hours to bake things. Okay, so I don't know why they're limited to 3 hours to bake in their one oven, but that's the limitation that we are working with in this example. Okay, so with that limitation of 3 hours, in order to make mini muffins, this baker is going to have to make fewer cookies. They're going to have to cut some of the cookie production in order to make the mini muffins, because previously they were using the 3 hours. If they were making 216 cookies, they didn't have any time left over to make anything else. Therefore, in order to add mini muffins, they're going to have to reduce the number of cookies that they bake. And this is what the baker has come up with. The circumstance is that they have these mini muffin pans, and each mini muffin pan can make 8 mini muffins, and they can fit 3 of the pans in the oven at one time. And since they can fit 3 in the oven at one time, 3 times 8, they can bake 24 mini muffins at one time. But here's the thing, instead of taking 10 minutes per batch, the mini muffins actually take 15 minutes per batch. And at 15 minutes per batch, in 3 hours, if we divide, 3 hours is 180 minutes. 180 minutes divided by 15, that's a maximum of 12 batches. 12 batches of mini muffins at 24 mini muffins per batch, that's a maximum number of 288 possible mini muffins that they can bake. So here's the thing. This baker can bake 216 cookies or 288 mini muffins or some number of cookies and mini muffins in between. And this baker has created a list of all of the possibilities for them to produce mini muffins and cookies. So it is a production possibilities table. And one possibility is they could make 216 cookies and 0 muffins. Now, if they want to make 48 muffins, that's going to take 30 minutes. So they have to cut 30 minutes off of the cookies. That's 3 batches of cookies. So they got to cut down 36 cookies. So their cookies are going to go from 216 down to 180. So another possibility is they could make 180 cookies and 48 muffins. Or they could make 144 cookies and 96 muffins. Or they could make 108 cookies and 144 muffins, or 72 and 192, or 36 and 240, or they can make no cookies at all, and they can make all 288 mini muffins. These are all of, now technically there are more possibilities than this, but these are the main possibilities that maintain the efficiency of the time in the oven. Okay? So what we have here are a bunch of production possibilities. Then when we graph all of these production possibilities, this is what we come up with. We come up with this straight line here, okay, this linear graph. Now, technically speaking, this is not the production possibilities frontier, because the production possibilities frontier is not a straight line. It's actually a curved line. But I wanted to get you started, and I wanted to get you to understand this idea that every time that baker approaches the kitchen with 3 hours to bake, this is the decision that that baker has to make. How many cookies am I going to make, and how many muffins am I going to make? There's a whole bunch of different possibilities of mixtures of cookies and muffins, and I can only pick one of them. If the baker decides to make 72 cookies and 192 muffins, then all of these other possibilities go away. They're gone, okay? This is something that we do often in economics, is we split the decision. Whenever we have a decision to make, especially a production decision, we split the decision between two options. Our main option and our second best option. That's called an opportunity cost, okay? And so when this baker is trying to make a decision, they may say, well, I don't want to make I don't want to make all muffins and no cookies, and I don't want to make all cookies and no muffins. I want to make a mix somewhere in between, so they're going to have to choose one of these other options, okay? So the idea of a PPF is the idea that we're looking at a graph that helps us understand the different mixes of possibilities of production, okay? Now, what we have here is this. Now, this all goes back to the idea of productive capacity. Okay, the productive capacity here is the maximum number of cookies is 216, and the maximum number of muffins is 288. And on the frontier, we always put the maximum number of each item on the axis. You can see that this vertical axis is muffins, and so you can see that we have marked up here, there's about 288. So we've marked 288 muffins on the vertical axis. Note also that it is the point 0 and 288. And so at the point 0 and 288, this is 0, 288, we are producing 0 cookies and 288 muffins, because muffins are on the y-axis, the vertical axis. Down here, this point is the point 216, 0. That's that point right here, meaning we're producing 216 cookies and 0 muffins. And then all these points in between are, for example, the point 180 and 48 is right about here. 180 and up to 48. This is the point 180 and 48. And so every point on this graph represents a different mix of cookies and muffins, okay? Now, the basic idea goes like this. The line represents maximum production. Maximum production. We can produce anything that is on the inside of the line. So, could we produce 100 cookies and 100 muffins? Well, that's that point right there. The answer is yes. We could produce 100 cookies and 100 muffins, because that is on the inside. This is the inside, this is the outside. Inside of the frontier, outside of the frontier. The frontier is the curve itself. That's the edge. That's the limit of production. And it represents, this limit of production represents productive capacity, the maximum output that can be produced in an operation. So, this baker, the maximum that this baker can produce is all of the mixes of muffins and cookies that run along this line on this graph. And so this is the PPF. Although, like I said, technically the PPF is curved, not a straight line. And so we're going to get into that in just a minute. But first I want you to understand, the very first thing I need you to understand is that anything that is inside the frontier is possible, but it's inefficient. Possible, but inefficient. Any production that is on the curve is possible and efficient. So it would be efficient to produce 216 cookies and 0 muffins because that is on the curve. It would be efficient to produce 0 cookies and 288 muffins because it is on the curve. And every single point along here, all these combinations represent efficient combinations of cookies and muffins because they are on the curve. Now let's move outside of the curve. This region over here is the impossible region. It's not possible for this baker, given these parameters, given 3 hours and 10 minutes per batch on cookies and 15 minutes per batch on muffins, it's not possible for this baker to produce any mix of cookies and muffins that's out here. So can this baker produce 150 cookies and 150 muffins? Well, that's right here. That point is right here. It's outside the PPF. Therefore, no, it's not possible for this baker to produce 150 cookies and 150 muffins. Okay, it not only is it an issue of effectiveness or efficiency, it's really just a question of impossibility. It's not possible to produce 150 cookies and 150 muffins. Okay. All right, so now that you have the basic idea of the PPF, what we're now going to do is we're going to move on to a specialized situation where we learn that this actually is not a straight line, it's actually a curve. All right, so what I've done here is I've made some changes. I added something, and here's what we need to understand. Okay, look at it over here. I want you to notice something. You may have noticed this before, that when the baker started making mini muffins, they purchased 2 new cookie sheets that cook 9 cookies instead of 12 cookies, but they also take up less space in the oven. And so what this baker can actually do is put a 9 cookie sheet in the oven. See, they can put 3 8 muffin pans, so 1, 2, 3, 4, 5, 6, 7, 8 mini muffins, 8 more mini muffins, and then 8 more mini muffins. Okay, so 8 and 8. Okay, so that's 24 mini muffins. But if they take 2 of the mini muffin pans out, they can leave 1 of the 8 mini muffin pans in and put in a smaller cookie sheet, and the smaller cookie sheet will cook 9 cookies. And so the baker can now make more use of the oven to mix up the production of cookies and mini muffins. Now, because mini muffins cook for 15 minutes and cookies cook for 10 minutes, they're going to have to open the oven, swap things out, close the oven. They're going to be opening the oven a lot. Now, we're going ceteris paribus here. We're not worrying about additional variables. We're just sticking with the idea that cookies take 10 minutes, muffins take 15 minutes, and we're just figuring out how we can mix and bake cookies and muffins at the same time. If we can cook muffins and cookies at the same time in the one oven, we now have a new mix of possibilities for production. And I put this here. Now, if you want to spend a lot of time, I spent a lot of time trying to figure out this mix. And I'm just summarizing it for you. If you're a math person, you can knock yourself out and try and figure out how I came up with these numbers. But those are the numbers. So this is the new mix of production possibilities when we throw in the fact that we can cook muffins and cookies in the oven at the same time. And I've plotted these points on the graph here, and now here's what we have. I've plotted all these points, and look what happens here. Instead of being a straight line, this list of possibilities for production, it kind of bows out. It comes off of the straight line. It still starts at 0 and 288 at the well, really, it starts at 216 cookies and 0 muffins, and it still ends at 0 cookies and 288 muffins. But in between those 2 points, it bends outward and gives us the possibility for a few more cookies and for a few more muffins given the same circumstances, okay? And that bowed line here is what we call the production possibilities frontier, or the PPF, okay? And so given that, what I now want to do is I want to leave this specific example and I want to move to understanding the theoretical and ideas and usefulness of the PPF. All right, so here's a much more simplified version of a production possibilities frontier. And I want to just point out maybe 3 or 4 different points, things that I want you to understand. The first thing I want you to understand is that the production possibilities frontier is a decision-making tool for understanding how to choose between 2 options, so option A and option B, okay? The second thing I need you to understand is that it is a graph, and so it is a coordinate plane. There is an X and a Y axis, or in this case, it's an A axis and a B axis, okay? So here's what you need to understand. The first thing I want you to understand is that any point on the curve is possible. Okay? So let's say that this point right here is point A, this point here is point B. Let's say this point here, which is a lot of A and a little bit of B, so a lot of A and a little bit of B, okay? So here we go, this much B and this much A. We're going to call that point C. Let's say this point up here, that this point is a lot of B and a little bit of A, okay? And then we're going to call that point D. And then let's say that we want a lot of A and a lot of B. Well, that point would be up here. A lot of A and a lot of B would be right here. We're going to call that point E. And then let's say we're going to do a little bit of A and a little bit of B, and we'll put that point right here. Okay, we'll call that point F. Okay. And so if this is a baker, or if this is a car producer, or if this is some sort of, or a computer producer or a phone producer, let's say a car producer, they may have to make a decision. Option A is cars and option B is trucks, pickup trucks and passenger cars. And they have a limit on how much they can produce because they only have so many engines, they only have so much metal, they only have so many tires, they only have so many manufacturing facilities. So they have to decide, are we going to build, more cars than trucks, or more trucks than cars, or maybe a little bit of each? But I want you to notice something, that because the curve is bowed out, typically you can produce more when you produce a mix of 2 things. So that's the second thing that I want you to understand, is usually you will get more output when you produce a mix of the 2 options. Okay, and here's what I mean. Let's say that if we only produce trucks, we're up here at this point here, right? Okay, let's say that that's 200 trucks, okay? And 0 cars. Well, this point right here, that's close to 200. What if that's 190 trucks and let's say 50 cars? 50 cars. Well, now you're getting 240 altogether where you would have only had 200. By producing a mix of the 2 options, you actually got more overall. And that's one of the things that the production possibilities frontier tells us, is that usually it's better to do a mix of the 2 options than to do all of one or all of the other. Okay? So the second thing I want you to understand is that. Okay? Now here's the third thing that I want you to understand. We could produce 50 cars and 50 trucks, but that means that we're not using all of our resources. See, this curve right here is the curve of possibilities. And anything on the inside, so the third point I'm going to make here is any point or combination inside the curve is inefficient. It's inefficient. What I mean is this, is you could be producing more because if you produce 50 and 50, well, you could also produce 100, well, let's say that this is 75 and 75, and you're still on the inside of the curve. Let's say that that's point G. You could produce more of both, and it's still possible. That means that you must have been wasting resources or not using them to the best of your ability. And this is akin to, see, this any point on the curve is possible. Well, the curve itself represents productive capacity. And we just learned about that. Productive capacity, isn't that the maximum? Isn't that the maximum production? Well, if this curve is the limit of everything that's possible, then it represents the maximum of everything that's possible. And therefore, this curve, the production possibilities curve, production possibilities frontier, it represents productive capacity. Well, if we're producing less than productive capacity at point F or G, that means that our capacity utilization must be less than 100%. And and that means we're being less efficient than we could be. So any point on the inside of the production possibilities frontier is less efficient than we can be because we're less than 100% on capacity utilization. Our actual output is less than our maximum output. All right? And so that's another thing that the production possibilities frontier can tell us. And then the last thing that I want to talk about is the production possibilities frontier is a great tool for understanding the idea of expanding productive capacity. How can we increase productive capacity? Well, we can increase productive capacity by expanding out the production possibilities frontier. By moving this curve out, I'm going to grab a different color here. If we were to expand out the production possibilities frontier so that it went out here, then look, we could now produce point E. That would then be possible. But the question is, how do we move the production possibilities frontier out? Well, the idea is this is, do you remember when we talked about productive capacity? If you look back in your notes to a couple videos ago, we talked about increasing productive capacity. How do we increase productive capacity? We can increase productive capacity by increasing the quantity of our factors of production and also by increasing the productivity. Remember, quantity is the same thing as stock of factors, okay? And we can also increase by increasing the productivity of our factors of production. If we can make our factors of production more productive to where each factor of production can make more, if we can get more out of the wood, if we can get more out of the cow, if we can get more out of the worker, if we can get more out of the truck, if we can get more out of the machine, then we are increasing the productivity of those factors and we will increase our productive capacity. Remember, productivity of the factors, that's a question of the quality of the factors of production. Okay? Now, last thing I'm going to say about this is the way that we increase the stock of factors and the way that we increase the productivity of factors is usually through several things. Through education. Education will improve labor. Through innovation. And through the use of improved technology. And so, of course, technology goes hand in hand with innovation. But innovation doesn't have to be technology. Innovation is just simply an issue of creativity. We can not improve technology and still innovate. We can use our existing technology in better ways than we used to use it, and therefore increase our productivity of our factors. That's just simply an issue of innovation. So education of our labor, innovation of our capital and our labor and our land, and then technology improvements, which is usually strictly a capital issue. If we can improve our technology, then by improving all three of these things, we will increase our productive capacity, and when we increase our productive capacity, we will expand out the PPF, the Production Possibilities Frontier, and then that expands how much of option A we can do and how much of option B we can do. We can get more and more and more out of our resources, and that's the whole idea that we're learning here in economics, is that we have a limited number of resources. We have an unlimited number of wants. We want to try and meet as many of those wants as we can with our limited resources. So we want to expand out the Production Possibilities Frontier. We want to increase our productive capacity in the economy. And in order to do that, we have to get more factors of production, and we have to make those factors of production better through education, innovation, and technology. And we can understand all that with this little tool that we call the Production Possibilities Frontier. So I want you to understand these 4 points. Those are all very important. I want you to understand this education, innovation, and technology. And I want you to think about them on your own. Well, that's all I have to say about the Production Possibilities Frontier, and I'll see you in the next lesson.